Ladies and gentlemen, welcome to Job Shop USA. My name is Keith and we're in my job shop, Turn Right Machine Works. Before we get into our project today, let's go in the other room and take a look at that shaft that we repaired from Wisconsin. All right, she's all together and ready to go back into the tube. We were able to take out the majority of that bend that you saw wobbling on the end, pretty close to the wobble that's on that one. Okay, we're going to talk about that one in a minute. The way I actually use, you see me straighten the struts with that plate assembly and the hydraulic press, and I call it the rock. Well, we have prop rocks as well, and this is a slug with a taper bore, and you put this in here and it lets me manipulate the shaft using the sleeve and protecting the taper surface itself from being damaged or distorted or bending in the middle of that taper. It's very important to maintain that taper. So the prop rock is what I use. After that, we bring it in here and we heat straighten it. It took me almost 15 points of heat straightening to make this run. There isn't a single surface on this thing that's running more than 1.5 and less than that in all the critical areas, meaning the taper, the area between the strut area here and the packing area and the coupling area. Those have all got to be running exactly right. You don't want any whip in the middle of your shaft, that's for sure, but that's still, it's not a critical contact area. It's open air or open water surface. All right, so there's a good view of that straightening project, and it's on its way back to Wisconsin now. Besides shaft wise, 1 inch to 1 3/8, and from state to state, Wisconsin to Cape Cod, there are slow rocks out there everywhere, and you got to watch out for those slow rocks. All right, now this same kind of bend, and I got to be able to push it back in the opposite way it was pushed. So you actually have to have a representative of the prop, because the prop was on here and the force was against the prop, so you have to put the force backwards on the whole strain of the shaft in relationship to the cutlass bearing support, because that's where it was held rigid with here, and then it was hit against the prop. That caused that bend in there. And there's also a little bit of a reverse bend in here. There always is. You can't, this is a fulcrum, so even though most of the bend is out here, there is a certain amount that's in here as well. We got about 6 right there, and probably you can get more right in here. We get about 8. We'll get on to our rest of our program. I just wanted to bring this in, and I wanted to show you results of my service, and another one coming in that's bit the dust, and we'll turn it around. We got the mate from the other side. There was no major bends on it. It passed a die check, I had to turn around and look at it. Make sure I wasn't fibbing. We did die check it. So we're going to be straightening this out, and we'll be checking the other one for a run out, and then we're going to get the new couplings on it and get this going as well. A reminder, repairing your shaft is much cheaper than replacing it. Have a shaft check today. Bring it in. All right, let's move on to my project at hand. In fact, actually I have 4 projects, and they're all going to be water jetting projects, and I'm going to do them on my Wazer Pro. Now, those of you that don't know that I had a water jet, or even that I have it or haven't seen it yet, this is my second water jet machine. I actually started out with a Wazer desktop. I purchased it. Wazer gave me a discount for shooting some videos on how I use it in my shop, and so they support me, I support them. Then they came out with this model here, and because I was so impressed with the desktop, I traded my desktop in, and I purchased the Wazer Pro, and I'm very, very satisfied. And there again, I did some videos. They sponsor me, I sponsor them. Just last week, I actually had a phone conversation, just a one-on-one kind of questionnaire on things that I think could be improved and or accessories added, that kind of thing. It's kind of fun to play with the engineers and the designing of it. All right, with that said, let's go on to what I got going on here. My first project is nonprofit because it's for family. Okay, when it comes to family, that's nonprofit. Okay, I assure you. Although my dad, see, I grew up with we had business. You know, I grew up with business in the house, and you know, we owned our own company when I was a kid. Actually, several of them. But my dad said, remember, you have to charge friends and family double, otherwise you'll get taken advantage of. And you can make your own judgment on that. There is some truth into what my dad was telling me. And basically, you know, it does work out. Because if somebody's taking advantage of you, you definitely know what the price is going to be for the next project, right? Okay, so family has got a little golf cart, and the back storage box on the golf cart has 2 really light duty aluminum hinges that lock it. There's a pivot hole here, and the thing just basically drops over a 1/2-inch pin on the gate. So the gate comes up and it drops in. But they were just trying to make everything out of, although this looks like it might have been plasma cut or water jetted at one time. You know, you can see that surface. All right. But this thickness right here, and you know it has a piece coming over here. Where's the weak point? I've redrawn this part, and we're going to be cutting it out. I would normally make this out of 6061 3/16 thick. This is 3/16 thick, but I only have 50 series aluminum. It's bendable, but with my added shape to it, we're probably going to have a strong enough part that's going to go in there. Non-profit, all right. So let's get ready and set up here. All right, I got to take out this piece of glass. This is a piece of borosilicate glass, also known as Pyrex or shot glass. This glass resists clouding and pitting, and is highly chemical and heat resistant. There's the 5 little circle. I think there was 6 there. This piece broke off here, taking a screw out. So you know you got to screw this down to your deck here, and so I think that broke off there. This was a snowflake I made for Lisa, and right here is a cutout for the travel dial on the closing. The other day was the last straw. That means I pulled it off and I measured it, and I came out here and I cut a glass, and then I stuck it in the face and mounted it back onto the closing. And here's a good picture of the finished product. And I'm a happy camper again. Okay, let's get this taken out and put it away for another day. Like the plasma cutter and probably even laser and maybe a few other cutting decks. That's the best way to describe this. This is your deck that you mount your projects down to. So it eventually starts getting cut up. Here was a repetitive cut that I had right here, and you can see that it's pretty well eaten it up, and then here was a aluminum flange that I cut up. So I'm going to move over, and I think I'm just going to pick that lines right there. So, and you can see the lines on the grid actually come up into the WAM program that I use to lay the things out here. Now, our component is a little bit bigger than this, so I'm just going to be laying it out. I know that, you know, this area right here, I can look at, visualize that in on the WAM program, and I'll be able to place my parts where I want them. You know, the tailgate uses 2 of these pieces. I'm probably going to cut out 4. I want to start out. I drew this in my Fusion 360, and here's the DFX file on the Fusion 360 drawing board. All right, then I imported it or brought it into this computer, and we're just going to open up the file here, and there it is. All right. Now, we'll grab a hold of it, and we know that our piece of material was at least 2 squares over and 1 square down, so we can start anywhere in this area right here. And then if we want to add another one, we can add another one. Let's just go ahead and we'll put it right next to it there, and we'll add another one. That's the 3rd one. We'll bring it right there, and we'll add a 4th. And I believe that that will fit in there because the square came down to here and went on up about this area here. This one might be close. I might actually have to run this one down in here. I'll quickly go look at that. By my guesstimation, it may clear, but I'm going to bring this one down a little bit, and I'm just going to bring this one over here just a little bit like that. I know that that will sneak by it right there, because this is the square right here that it cuts across. All right. Now that we got all 4 of those in there, we've got them locked in there, and we can just go ahead and pick our materials, which is going to be easy. It's going to be aluminum, and okay, it's all under 6061, but we're just going to use it as a general rule anyway. And we're going to go ahead and take the 1/4 inch that's on file here, and then we'll cut it on the coarse path of that, because there's no 3/16 set up for it right now. We want the cut lines all to be on the outside. We got that. I'm going to go for no tabs. I just want it to cut clean. The little hole might blow out, but that's fine. All right, the cut, we're going to go for a coarse. Estimated time to cut all 4 of these out is going to be 19 minutes. It's going to use about 6.5 pounds of abrasive, and the estimate cost of actually cutting this with the abrasive is $5.12. That includes a little bit of the wear and tear and everything else on your machine, your nozzles, your replacement of your consumables. That included in that $5.12 on the cost of this. Okay, I'm going to generate the file, and we're putting it in here, and we're going to call this Matt's gate latch. All right, and save. All right, it's already in there. It's done. We can eject. All right, safe to move it. Let's go cut it out. Here, and we find Matt's gate latch. All right, and we hit OK. Prepare machine to cut. Yes. Okay, lift nozzle. Got to lift it up, and then you hit OK. Okay, see what I was talking about? Setting the screws right in this corner. Keep them away from that corner, just because you know that you're going to set, you're going to be setting up. But this actually kind of comes and lets you know that corner, your project is in that corner. All right. So now we're going to say the right material. Okay, fill the abrasive hopper. Okay, let's fill the hopper. It's not that low because I don't usually let it get low, and I keep it up, and I haven't had any real long projects, so might just take a couple cups of my containers here. You can see that that's already pretty close. We'll do a little bit on this other side. All right, material's good. All right, confirm water's on. Water's already on. Also too, one thing that you can always tell, which I like to start it with water because I like cutting it underwater. That'll be close enough. It'll catch up when it gets there. Okay. All right, set the nozzle. Okay, when you set the nozzle, take this the gauge. All right. Now cut material. All right, then press start or OK. Okay, now I didn't put the camera inside to watch the cut on this project here. I'm going to do it on one of the projects, the pieces that we got coming up, because it is something a little out of the ordinary. Okay, I saw the first piece popped out of the socket. I'm going to stop it after it finishes piercing the hole, the pivot hole on the second one there, and we'll lift the lid and we'll pull it out and we can get a good look at it. Okay. See, it just popped out, and so it doesn't go over the edge and fall into something. All right, here's the little hole that it pierced, and here's the other little hole it pierced. Fantastic. This is where it pierces in, makes a cut around. We're just going to make sure that this a ½ inch slides into there. We'll probably chamfer that on both sides there. Make sure the 1/4 inch pin or 1/4 inch bolt, that's what is held in place, so that this thing will go like that. Plenty of material over the top of it here. Pretty cool. All right, let's get going again. Okay, I just wanted to stop it because we're getting ready to blast between the second one and the third one here, and I didn't want them popping out and worrying about them, so we're just going to stop it before we do the last one here. we go. That was our last one there. I'm going to get my hose here. I'm learning that I can rinse because the thing has an automatic drain and it drains down so far. So okay. That'll drain down, take care of itself. Then we'll get that off of there and we'll get moving on our next project. But we're pretty happy with our cutouts there. All right. We'll chamfer that, run a reamer down to just make sure that we're a 1/4 inch there, and dress this, make sure a 1/2 inch flies up and in here. Leave it as tight as possible because they're going to wear. All right, I thought you would want to see how the prop rock works. All right, we got our shaft in here. This is just under 8-foot shaft. So I've supported out here. I have a platform out here. I throw some of my 4x8s in here, and I got my roller out here. Now here's another example of the right rollers helping with the job, and the trunnion action of it just sitting up on the blocks there, and then this one here sitting down on the table. Of course, the trunnion is slightly downhill like this, but they're in line, and I'm able to indicate the end of that shaft. All right, now let me bring you in. Let's see if I can just do this real quick here. All right, so we're gonna roll it around. It's kind of close to zero, okay, within a thousandth or so. All right, but and we already saw it wobble, right? Okay, so we're gonna roll it over. There's 1, 2, 3, 4, 5. A little bit over 5, so a little bit over a 1/2 inch. Um, and in relation to the axis, it's only bent a 1/4, right? So it's a 1/4 on this side here, and it's a 1/4 less on that side, right? All right, let me zoom you back out. We're sitting on the table. Okay, let's move the indicator out of the way because it's really not doing us any good. And I know that this is the top, so I'm just going to do that. All right. All right, we slap on the prop rock. All right, it's on there. So now we're protecting that tapered surface. Now we want to use this as the prop. So we're going to bring this in, and we're going to slide it a little bit that way because we need to be over it. All right. So this end of the prop is being supported here. And we're going to push on that end of the prop over there, and that's going to twist the prop. The support's going to be the center right in here, and we'll find a piece in here. That's gonna be good enough. Okay. Prop, strut. Okay. One, two, almost 3. So we took out just a little less than half of it with one push there. That's how this prop rock works. I just thought I'd give you a quick look at it. while we're doing everything else. All right, move on to our Wazer projects. All right, our next project for the Wazer is this valve plate. This is a reed type valve plate for an air compressor. This is the flap for the intake, and that's the exhaust port there. You can see right there the edge is wasted. There you go. All right, a couple things about this. Well, you can see the cutout and the port here. You can see there's a little bent up tang right there. All right. It was really kind of a question of what material am I going to use to make this. I took my micrometers and I'm getting about 13 thousandths thickness on this. So I started doing some research in different alloys of stainless steel. Now I knew it was magnetic because I can stick a magnet to it. In fact, actually you could probably put that down on the surface grinder and you could hold it and probably grind the side of it. That's how much magnetic strength it actually has to it. So, and I've in the shipyards I've had experience with magnetic stainless. And so I did some research and I'm looking for sheet metal, sheet material, and in an alloy of stainless steel and handles what I needed to handle. So I chose, and this is what I'm going with, stainless steel grade 440A. It's a high carbon martensitic stainless steel, known for its excellent hardness, wear resistance, moderate corrosion resistance. It contains about 17% chromium, and the carbon content's about 60%. That's where you get that draw of the magnet, to 75%, which contributes to high hardness and strength after the heat treatment. This alloy is magnetic, both in its annealed and its heat treated state. So no matter what you do to this, it is going to have that. Primary applications for 440A stainless includes culinary, dental, surgical instruments, pivot pins, and valve parts, where a combination of wear resistance and corrosion resistance is required. All right. They also make knife blades out of it and some other things like that. All right. And then it gets into the heat treat and the hardness and all that. I don't really need to get into that. So that's my choice of material. All right. And I got a piece big enough. I'm going to go ahead and I'm going to get my customer a part. Hopefully, you know, it's yet to come about. Let me take you through my process to get it to where it's even going to get to the Wazer. All right, first off, I actually took my part and I laid it down on the face of my printer scanner, the regular printer scanner you'd use for copying your paper and stuff, because I can also import that kind of a file and hold the tolerance in the exact size. And it's showing right here in this file here on my plasma cam. Design Edge software lets me bring photographs right into it. So here's the photo that I imported from the scanner right into my Design Edge software. All right, so it gives me the good shape here, and it can create some fixed lines right off of the photo, but you have to dress them up to finish that up and make it complete. But anyway, here's the photo that I imported, and then here's my smoothed out shape that I want from that photo. and then I transfer that into my Fusion 360. All right, once I bring it in, import it into my Fusion 360, and I save the file in there, and then I can export it as a DFX once again to either back to the plasma cam to actually cut, or I could send it to the water jet and have it cut, or I can take it from here and create a shape out of it, and then throw it into either one of my three-dimensional printers with an STL file. So it kind of it's I like it. I like to draw with it, but I also like it as my medium point of serving a lot of the needs I need for CNC. All right. Hey, I just wanted a quick share here. This is a gooseneck. This is polycast. I 3D scanned from aluminum housing or aluminum part. They had a broken off ear. I repaired it. They got it back into the boat. They're doing their regatta or whatever they're doing, and I have a sample. We're going to be doing some aluminum casting here soon. All right, let's head on over this direction. I took the material out of the package, and you can see surface grinding marks on there. All right. All right, I brought my imported piece in here. I decided to put my piece right here in the center, so that 4 square by 2 square high is my plate in on the table right now. So I'm going to give myself a little bit of room here, and I'm going to place one right there, and I'm going to go ahead and add in a second one, and I'm gonna put it like right there, because I could probably have another one up over here. I don't know if I'll have a fourth one, but I know that I can at least get those in there like that. If I get 2 of them, that's going to be great. I wanted to point out that this little port right here, I had to widen the 2 spaces on each side of that ear so that I could get the cut to go in there. All right, so we're going to go back to scale and position. We like that. Material. I'm picking titanium, grade 2. So the only file in here is 35 thousandths thickness. This is tough stainless, and my 2 choices of stainless are light duty compared to this stainless, so that's why I chose that. Okay, I want the cut pads on the outside. Now the tabs and the lead ins, I picked them on this one here, and on this one here I'm no tabs, and then I'm going to manually place them. As soon as I get it here in view here. Okay, I like this area right in there. Okay, we want to make sure that this is down in that size there. Okay, I like that one. The other one I put like right here, and then we placed one just outside here. All right, there's our placement. We've got everything set to cut that out, all of our perimeters. We're going to generate a job file. We're looking at 11 minutes, 11 and a half minutes, and we're looking at $3.01 estimated cost to cut this out. All right, let's generate a job file here, and I'm going to call it read valve plate. Save. Okay, it's already in there, and Eject. Safe to eject. All right. We got our file. Let's go cut it. I'm down to setting my nozzle height here. And we like that. All right. And it's the cut material. Okay. Close door. Hit start. I gotta stop because it doesn't sound right. It's like I'm not getting any abrasive. We cleaned out our hose and we are ready to try it again. Here we go. Looks like we have success. Through this dirty glass and through the layer of water, it actually looks pretty good. We may stop this right after this one cuts out because I don't want to lose the part over the side. So I'll pull this one out while the next one cuts out. Okay, part one is done. I'm stopping it right there because I know if I don't get that part, it will go flying over. All right, we're going to let the next one cut out. Let me blow it off. That's pretty badass, I think. Pretty badass. I've been looking at my inlet pressure and a couple other things there because every once in a while my machine tends to just fluctuate a little bit, like drop off the high pressure there. It's not affecting the cut, but it does make just a little bit of a tapping noise there. And but it's not constant. It'll go away, it'll come, go. My inlet pressures, I'm in the limits. My volume, nothing is Nothing is restricted. I'm running off hours right now, so nobody else in the building's even using another water, so. All right, success. Um, with the exception that I got to bend that little tiny tang over, which I'm going to put it in the machinist vise like this, and then I'm going to tap it with the punch at the same angle that I believe it'll be. So I'll put the other one in there. I'll look at that angle, hold the punch at the same angle, and then give it a little tap. You only need to have that bent down just so that helps register it. I'll double check on the diameters and make sure everything's 100%, and the valve should work perfect. Ever so slight little edge on here. We decided to just use my fine little file here, sit on comfortably, kind of go around the outside edge here. Doesn't take nothing to roll that off of there. I know we were talking about going in the tumbler or whatever. I'd have to get up and get on the ladder and get it down here. And then this is actually such a nice surface on here already. I don't want to take a chance on messing that up. And this really doesn't take that long. Okay. All right. This is our third one. We cut this one out this morning. Last night was so great that we actually ended up creating exactly what we wanted, and just another plus for the Wazer. All right, the tang's on this side, that direction there. So I'm gonna close this in on the vise, just where the bottom of those two, the relief on each side of that tang, and kind of hold the punch up. So the punch is basically about that angle right there. All right, about 2.5 inches up from the vise on the bottom here. All right, I don't know if that's scientific or not, but we're gonna also too make make sure the tang's going in the right direction. Okay, so we're gonna make sure we're doing that right. All right, here we go. All right, and right there, and center, and about 2.5 inches up there, and all right, and that snapped that one right off of there. All right, it doesn't take impact, at least sharp impact. Heat will create warp. There's 2 and 2. I looked real close at it, and it is bent, but I may have just tried to bend that too sharp. It does have a little curve and a little deflection into the plate right there. So there. I think we'll bring out the magic tool here.